A uniform wire of 16 ohm resistance is made into a form of a square. The two opposite corners of the square are connected by a wire of resistance 16 ohm. The effective resistance between the other two opposite corners. So we know there is a wire whose resistance 16 ohm, and it is made to or convert into a square. Square means all the sides are same. So length will be therefore equivalent. So 16 ohm is a total resistance. Therefore it divided into 4 different wires of the branches, and therefore each branch will have a 4 ohm. So therefore it forms a square. So each branch or each side having resistance 4 ohm. So 4, this also 4 ohm and 4 ohm. Let me name this as A, B, C and D. So total resistance becomes, it is 16. There is one more wire which is having resistance 16 ohm, is connected to the opposite corners. Maybe I'll take B and D, these are two corners connected by a wire whose resistance 16 ohm. Now the question is, find the effective between the remaining two opposite corners, that is between A and C. The effective is asked between A and C. If I rewrite, it is point A, we have one resistor which is equivalent to 4 ohm. We got a point B, then we have a 4 ohm connected to point D, then D to C we have 4 ohm, we got a point C, and B to C we have 4 ohm. Across DB we have a 16. So across A and C effect is asked. When you want to find A and C, effective between A and C, you have to consider these 4 resistances. Of course, we have 4 resistances. If I turn little bit, it is A. We have 2 branches of 4 ohm. I'll raise the point to D. Then D to C, we have one resistor. It's a 4 ohm. These two over. So we got a point C. Then I'll move from A to B. We have a one resistor, point B. Then B to C we have one more resistor which is equivalent to 4. Now across DB we have one more resistor 16. Now this equivalent to Wheatstone network, and this Wheatstone network is balanced. It's a balanced Wheatstone network. And whenever it's a balanced, we know it's a 4 divided by 4 and 4 by 4. It's a balanced. Therefore, 16 ohm resistance is not useful. Eliminate. Remaining is, it's a 4 ohm resistor. You'll get a point D. Then we have a 4 ohm resistor. We'll get a point C. Below once again same structure 4 ohm and once again 4 ohm. We got a point A as well as C. Now these two are in series, therefore effective is 4 plus 4, it is 8 ohm. Below we got 4 plus 4, that is 8 ohm. Now these two are in series between A and C, therefore effective is just one resistor. They are in parallel, 8 and 8 parallel, so effective is therefore 4 ohm. 8 into 8 divided by 8 plus 8, 64 divided by 16, it's a 4 ohm. Therefore effective resistance between A and C opposite corners, it's a 4 ohm, and that is given as option D.